Hey, good day, everybody. Welcome back and Happy New Year. Today, we're continuing with Web Tutor Online's lecture series Phys 101, and today we're doing moments. Right? Last day, I went through with you forces, and we looked at how to find the resultant and the magnitude of forces, either acting at horizontal and vertical to each other, or at perpendicular angles, or at some angle to each other. We also mentioned that there were forces that can actually create a turning effect, and that's where we're at. Moments basically are turning effects, and as you can see from our little diagram here, the little seesaw, there's a point at which our bar is actually turning, and that point is called the pivot or the fulcrum. And so the moment is actually calculated by finding the force and the distance of that force between the force and the point of pivot. We multiply those two and we get what we call the moment or the turning effect. Now, of course, depending on where the force is acting, you can get a clockwise or anti-clockwise moment, right? And so in this case, you're going to have a moment on either side, a turning effect on either side, right? The system that we're using to illustrate this here, of course, is called a lever, a simple machine, where, of course, one of the forces is going to be called the effort, and it's trying to overcome the resisting force, which is considered to be the load, right? So the law of moment states that when a body is in equilibrium, or, for example, when it has to be stable, as we mentioned in the last lecture, equilibrium means at rest, so nothing's going anywhere. The sum of the clockwise moments should be equal to the sum of the anti-clockwise moments. Right? What it simply means is for the beam to be stable, the moments on the left side should be equal to the moments on the right side. So turning effects on both sides has to balance each other out. Right? So that's a very important law for equilibrium. And in the last lecture, we looked at the other law. The other reason is that some of the upward forces or downward forces should also balance each other out, and that also brings equilibrium. But looking at moments here now, as you can see from our diagram and our example here, we can have a moment on the left side, a moment on the right side. So the force being exerted by the two different objects on the left and the right, and both of them are different distances from the pivot. So on the right side, the 40 Newton force is 1.8 meters from the pivot, and on the left side, there's a force acting that is 0.8 meters from the pivot. And so the moment on the right side will be 40 newtons, which is the force, multiplied by the distance 1.8 meters. And for this system to be in equilibrium, as you can see, the beam is balanced, the moment on the left side should be equal to that moment on the right side. Now, we don't know what the force is on the left side, but because we're using the law which says they're supposed to be equal in order for it to be in equilibrium, we can equate the two moments here and say that F multiplied by 0.8 meters is supposed to be equal to 1.8 meters multiplied by 40 newtons. And hence we can find the value of F on the left side, which works out to be 90 newtons. And so similarly, we can actually find distances from the fulcrum or forces. And that's the principle by which we use the laws of moments to work out certain things that we want to find out about our objects, the distances from the pivot, and of course the forces, right? So very important to note though, the force here actually is equivalent to the weight, because as you can tell, we calculate weight by estimating the mass by the gravity. And of course, force is also measured mass multiplied by gravity. F is equal to mg, W is equal to mg. And hence, weight actually is considered to be a force, and hence the units of it will be in newtons. And so, center of gravity of a body also is considered to be the weight, the point at which all the weight of the body is concentrated, or all the weight of the body acts. And it makes a big difference where that center of gravity of the body is. The lower the center of gravity is, the more stable the body, and hence has increased stability. If it's higher, the body actually is less stable. So that's important. in certain objects to know whether it's stable or unstable based on where its center of gravity is located. Okay, folks, I hope you learned a lot today on moments, and our next lecture is going to be on energy. So make sure to like and subscribe and vote, comment us. Keep revising your lectures because we want to keep going at a good pace, but we want to come back and do some revision as well. I want to make sure you're actually understanding the work. We'll probably have some sort of a quiz or exam or something. Right, but until then, keep it up, keep working hard, and I will see you next time.